Okay, question number 9 from WebAssign on universal gravitation. We have the Earth. Here's Earth, and its radius RE. And there's a G-field here at the surface, call it G, which is Gm over R squared. And the question is, to find the altitude above the Earth, where the gravitational field is a fraction of this gravitational field at the surface. So what I'm going to do, I'm going to draw this new radius, and let's call it R. Okay, there's R. But what it's really asking for is the height above the surface. So we'll call this H. So H is the distance above the surface of the Earth. Now, if you think about it, let's just get the high-level question taken care of here. Namely, that H is equal to, this H is equal to the entire radius, this new radius, minus the radius of the Earth. So I'm going to say R minus RE. When I say R Earth, that's R at the surface of the Earth. All right. Okay. So each one of your examples, they're asking for the G field here. That's a particular fraction of the G field here. So this G field, oops, this one here I should say R Earth, radius of the Earth. So I'm going to write here G is equal to big G, big M, same as before, the same G, same M, same mass, which is Earth, over R squared, okay, this new radius, is equal to, as the problem says, some fraction. I'm going to call the fraction y over x. Okay, so there's the fraction that you're given. So y over x times the G field at the surface, which is this. So y over x times G m over radius of Earth squared. So these two G fields, Gm over R squared, is y over x times this G field at the surface of the Earth. Okay, so G goes away, G goes away, M goes away, M goes away. And yay, we love that. So this reduces to 1 over R squared is equal to y over x, your particular fraction, times 1 over RE squared. Now to make that a little bit, let me focus that here a second. Is that focused? There it is. To make this a little bit more visually solvable, let's flip it. Let's inverse both sides. So we have R squared is equal to x over y, so take your fraction and flip it, of course, times RE squared. Take the square root of all that, and you get R is equal to the square root of x over y times radius of Earth. There it is. So that's your R. And that's probably enough. The radius of the Earth is given in the problem, which is 6.371 times 10 to the third kilometers. But if you wanted me to take it one step further, we were supposed to solve for H. So H is equal to R, which is square root of x over y RE, and then minus RE. So that's just simply equal to, we can factor out RE, times the square root of x over y minus 1, and that will be the answer to the question for your particular fraction y over x.